Good morning, everyone. I'm Maheswari, Electrical Department, R&D Engineering College. This video, I'm going to discuss about the subject High Voltage Engineering, and the topic is the measurement of high voltage and currents. So, in this video, the measurement of high voltage and currents, we are going to discuss about the specific topic generating voltmeter. So why we going for measurement of high voltages and currents? So in order to measure the high voltage in the industries and to measure the currents accurately, to give perfect safety to the personnel and also to the equipments, we have a requirement to measure this high voltage value. So the equipment it should be protected from zero voltage due to the stay coupling. So for these purposes, we are going to measure this high voltage and high current. And the electromagnetic interference is also a problem in the impulse voltage measurement. So different devices used for high voltages measurements differ from low voltage measuring devices. So about the today's topic, generating voltmeter, it is a high voltage DC measurement system. So the generating principle is used here is when the source loading is not permitted or when direct connection to the high voltage source is to be avoided, we go for this generating voltmeter, which is used to measure the high voltage DC. So a generating voltmeter is a variable capacitor electrostatic voltage generator which generates current proportional to the voltage to be measured. It provides loss-free measurement of DC and AC voltages, and it is driven by a synchronous motor. And this generating voltmeter does not absorb power or energy from the voltage measuring sources. Now, the principle of operation of this generating voltmeter is when a high voltage electrode excites the electrostatic field within a high insulating medium, either the medium can be a gas medium or vacuum medium, and the ground potential, the earth electrodes are subdivided into a sensing or picking up electrode. So, the sensing electrode or a picking up electrode and the guard electrode and the movable electrode, and all these are kept at the same potential. Every field line ending at these electrodes binds up the free charges. So for measuring purpose, the surface area of the electrode is considered, A is considered, and here the principle of operation in terms of expression. So the charge stored in the capacitor C is given by Q is equal to C into V. Now, if we are differentiating this current with respect to time, okay, and I equal to, we know the formula for the current through the capacitor I is equal to expression for the current, I is equal to dq by dt, which is equal to, when we differentiate it, is V into dc by dt plus C into dv by dt. Substitute here Q as C into V and then differentiate it, getting the expression V into dc by dt plus C into dv by dt. Now, for a DC voltages, this change in voltage with respect to dt is 0. So, the expression, current expression is equal to I is equal to dq by dt, which is equal to V into dc by dt, substituting this dv value by dt as 0. Now, if the C varies from C naught value to C naught plus Cm sinusoidally, then we can write C as C naught plus Cm sin omega t. So the current I is given by Im cos of omega t, where Im expression is V into Cm into omega. This Im represents the peak value of the current. Therefore, the RMS value of the current is given as V into Cm into omega by root 2. Peak value by root 2. This is the IRMS value. And we know the omega is nothing but the angular frequency in radians per second, which is given by the expression 2 pi n by 60, where n represents the RPM. Now, if the capacitance varies linearly with time and it reaches its peak value Cm in time, Tc by 2, the current expression we get it as V into Cm into the F value. So it is written as V into Cm into 2 by Tc. Okay. Now the construction of this generating voltmeter. The generating voltmeter with a rotating cylinder. You have a rotating cylinder here, which consists of two exciting field electrodes and a rotating two-pole electrode S naught. This is here S naught. Okay. This S naught is driven by the synchronous motor at a constant speed m. Here you can see the motor, constant speed n. Generating voltmeter employs rotating vanes for varying the capacitance between the S2 and S3. This is the S2 and S3. Now, with the design of vanes on the electrodes S0, the capacitance can be varied. So here the high voltage source is connected to the disk electrode S3. This high voltage is connected here and is kept at a distance from all other electrodes. Working operation of it, the generated AC current through the resistance R is rectified by using this diode rectifier, and it is read by this moving coil micrometer. In case if the current is small, an amplifier is to be used before the current is to be measured. So the instrument is calibrated using potential divider or spear gap. The generating voltmeters can be used to measure a wide range of voltages. Circuit operation. The rotation of this S naught produces the sinusoidal variation in the capacitance. The AC current proportional to the external voltage is generated through the resistance and is rectified, and it is measured by the moving coil instrument. So if it is value is small, we need an amplifier to maximize it. So this instrument, it is calibrated by potential divider or a spark gap. The advantages of this electrostatic voltmeter: the scale is linear and the extension of the voltage range is easy. It can measure wide range of voltages. There is no source loading here. It is zero. That is, this meter does not measurement device does not require any source from the sun, any source for operation. That it does not require power from the supply. So the source loading is zero. There is no direct connection to the high voltage electrodes. Now the limitations, it needs to be calibrated, and the construction should be carefully done, and any disturbances due to positioning and mounting of the electrodes make the calibration invalid. So it should be properly fixed. Thank you everyone.